All right, team, we're going to wrap up our adventure with writing quadratic equations and mix some review into it. Let's go ahead and dive on deep. All right, we're getting towards the end of our journey, and we're going to do a bunch of mixed exercises in order for us to get battle ready for our test. Number one, we got to go ahead and factor. So I'm going to create my area model and go ahead and put my x squared and -4 in the right spot to get me going. I know x times x is x squared, and I know that something multiplies by something equals -4. Now I'm going to look here, -3x. This is going to prompt me to make it a -4 and a +1, because when I combine these two together, it makes -3x, leading me to get my answer, x plus 1 times x minus 4. Now, I'm going to have to evaluate. Notice h -3. I'm going to put -3 for all those spots. Then, for k of 4, I'm going to go ahead and plug in 4 in. Well, let's go ahead and figure this out. What is the output when I put an input of -3 in? Well, -3 squared minus 2 times -3. I'm going to go ahead in the same breath, go ahead and get k of 4 and plug it in to -2 times 4, all inside of absolute values. Notice how I haven't even started in my auto process. Now, after I've written it out, I'm going to go ahead and solve. What is the output when x is -3? Well, -3 squared is +9. -2 times -3 is +6. Let me continue. H of -3. When x is -3, the answer is 15. When k is 4, I get the absolute value of -8. When k is 4, this results in +8. I'm almost done, team. What is h of -3? 15. What is k of 4? 8. 15 minus 8 is 7. Okay, analyze the graph. Describe whether each function could be used to model the graph and explain your reasons. Okay, let's check. So, concavity, that's the first thing I check for. My a values are both positive, so that's okay. A is a positive number. Now, I got to go ahead and figure out some things. This guy is in factored form, telling me that -1 and -5 are the x-intercepts. How would I represent that as a coordinate? Well, the x-intercept is -1, 0, and -5, 0. Now, does the graph cross the x-axis there? No. The graph does not have -1, 0, -5, 0 as x-intercepts. Argument failed. Now, even though it's probably going to be g of x, let's check. What is this form? Vertex form. So it's going to tell me that my vertex is hk, which is going to be 6, 5. It also tells me that the axis of symmetry is x equals h, which means x is 6. And it basically means as x equals 6, is there a line that cuts it in half? Okay. Where would this coordinate be? If I went over 6 and then up 5, technically it would be in quadrant 1. Again, let me show you what I did. I'm just testing. To do 6, I would go over to the right, and then k would cause me to go up, meaning I'm in quadrant 1. That matches the picture. So this is my argument. G of x can model the graph because the vertex is indeed in quadrant 1. Okay, keep on going. So all of these are essentially the same problem with different information given. For the first one, it gives you 3 points. Well, something brings my attention about these guys. With the 0, this tells me, let me go ahead and graph it. It would be over here and then over here. These are x-intercepts. And this causes me to use factored form. Okay, let's go ahead and continue. Now, I have to figure out, using factored form, f of x is equal to a times x minus root 1, x minus root 2. Now, let me substitute my roots in. My intercept is at 7. So it's going to be 7. And likewise, 6. Notice what happens. If I plug in 7 here, 7 minus 7 is 0. Hence why it works. Notice here, if I plug in 6, 6 minus 6 is 0, making this true. Now I'm nearly almost done. I have to find this a value and I'll be good to go. To do so, I'm going to use the x as 5 and the y as negative 4. Remember, it is always xy, x f of x. So using these values, I can eliminate some of my variables. And then I go into town. 5 minus 7, 5 minus 6. This turns into a times negative 2 times negative 1, which cleans up to be positive 2. I'm going to go ahead and rewrite this as negative 4 equals 2a. I'm going to divide each side by 2. Getting a is equal to negative 2. Okay, using this, I'm going to write my final answer. I am not using this in the final answer. It is going to be f of x equals negative 2, x minus 7, x minus 6. Okay, you're going to notice number 4 is very similar to number 2. Let's do number 3 though. It's a slightly different. They give me the minimum. They give me the minimum location and then a point. This immediately is x, f of x. I see hk. Why? This word right here. Minimum is a vertex. So, vertex form. I'm going to use f of x equals a times x minus h squared plus k. Plug in my numbers. I'm going to go a little quicker. 26 equals a times negative 3 minus 6 squared plus 20 plus k negative 1. All I did is I replaced my h with negative 6, my k with negative 1. I replaced my x coordinate, negative 3. And then I also replace my 26 with the y. Go ahead and turn on the autopilot, and I'm going to go ahead and start solving. -3 plus 6 squared minus 1. I clean up some grammar. I get -3 or +3 plus 6 is +3. I square the 3, and I'm going to write it in front. Now I'm going to use my inverses. Get a by itself. I get 27 equals 9a. I divide each side by 9, and it turns into 3 is a. Voila, critical information. Not done, not done. To get that 4, rewrite the equation one more time with x minus 6 squared plus -1. When you rewrite it, take attention to grammar. You're turning this into your boss. So I would instead say f of x equals 3 times x plus 6 squared minus 1. Whew. All right, 3 problems. Good luck, team.